Alright, here we're asked to identify whether a given set is finite or infinite. So think of finite as there's a certain amount of elements in the set. It ends. It's not going to go infinitely on. There's not an infinite amount of numbers that we could be listing them all day. Okay? So if we take a look at the first example here, we have multiples of 4. So we're just adding 4 every time to each number. Well, it has these dots here because it's not going to just end at 20. We could keep doing that. We could add 4 to 20 and then get 24, and then we could add 4 more and get 28, and then 32, and then 36, and add 4 more and get 40, and we could keep going and going and going. So this set here doesn't end. We could keep going and going and going. So it is infinite. Alright, here we have the set of all integers less than 0. So we have the set of all integers less than 0. So integers less than 0 would look like this. So they're all the natural numbers, so the counting numbers, but because it says less than 0, it's in integers, it means it's the negative of the counting numbers. So these are what integers less than 0 look like. So -5, -4, -3, -2. So integers are not decimals, they are not fractions. They're all the whole numbers and then their opposites. But because it says less than 0, that's why we're only including the negatives. So -1, and I can't end it. This set does not just have these 5 numbers. It says all integers less than 0. So that means it can keep going and going and going, that the numbers can keep getting smaller and smaller and smaller, so it doesn't end. We could also have -6 in our set, -7, -10, -20, right? So because it can keep, there's many other elements in this set, this is an example of an infinite set. Alright, here we have the set of all natural numbers. So natural numbers would be like 1, 2, 3, 4, 5, 6, etc. Well, it says the natural numbers that are just between 0 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so those are all the numbers that are in between 0 and 10 that are natural. So natural numbers are not decimals, they're not fractions. Think of like when you naturally count. The numbers you naturally count with are 1, 2, 3, 4, etc. So that means that this is finite because there's only those 9 numbers. There's not an infinite amount of numbers. Alright, here we have real numbers, and real numbers are all numbers. Decimals, fractions, integers, negatives, positives, all the numbers. So if we're going to list the set of all real numbers between 0 and 10, so in other words, it's not going to just be this, like the previous problem. Okay, that is finite. That was the one before this problem. But this one is not finite because it says real numbers, and real numbers are decimals and fractions as well. So in other words, we could have 9.1, we could have 9.112, we could have 9.25, we could have 4.5, we could have 4.5555. There's an infinite amount of elements in this set because in between just 3 and 4 there's an infinite amount. You could have 3.1, you could have 3.22. There's an infinite amount of numbers in between each of those natural numbers. Because we've allowed real numbers, that means all numbers. So this is infinite. Alright, last one, we have the set of all whole numbers less than 100. So whole numbers are like 0, 1, 2, 3, 4. They're all the counting numbers in 0. So that means no decimals, no fractions. So if it says the set of all whole numbers less than 100, I can actually list those. I can keep listing them, and it's going to end at 99. So my set is finite because, and I'm not going to list them all for you, just imagine that they're all here, right? 12, 13, 14, etc., all the way to 99. I can list them. Those are 100 numbers that I can list in my set. That's why it's finite.